So we start a new chapter, but the first section of a new chapter is always nice, isn't it? It always just reinforces some things that we already know. And we definitely have learned about triangles before, right? Does it take you back to elementary school, right? You know, a triangle obviously has three sides, but there's all kinds of special ways to classify triangles. We can either classify triangles based on how many equal sides they have, or classifying triangles by their angles. If we classify by sides, there's three names for three different kinds of triangles. If a triangle has three equal sides, you might remember the name. Do you remember? You are right, equilateral. And if you look at the word equilateral, it's kind of got both of those words in it. Equal means equal, and lateral means sides. So if a triangle has all equal sides, it's called an equilateral triangle. If a triangle here has two equal sides, do you remember the name of that one? You are right, isosceles. No real clue in the name, but isosceles triangles have two equal sides. And if all the sides are different, here, all the sides are different, that is called a scalene triangle. No equal sides is a scalene triangle. So if we look at a picture here, sometimes it has numbers, sometimes it has markings. So here I notice those two sides are equal, so that is an isosceles triangle. You can just write isosceles. What about number 2? 19, 19, 19. What kind of triangle is that? You are right, equilateral, all sides equal. 3, 5, and 6. All those sides are different, so you are right, scalene triangle. And then here with a 4 and a 4 is going to be another isosceles triangle. That should have felt really easy to you. You should have remembered doing that earlier in other math classes, equilateral, scalene, isosceles. Next is classifying triangles by angles. So we're looking at the angles instead of the sides. If we see a triangle with 3 equal angles, that triangle is called equiangular. Equiangular. Which, by the way, how many degrees would each angle be? Do you know? Well, how many degrees are in a triangle? 180, and if they're all equal, you could just divide 180 by 3. Equiangular triangles always have 60, 60, 60 for their angles. An acute triangle has one acute angle, one angle less than 90. One acute angle. So, or actually, I'm sorry, it has actually 3 acute angles. My bad. Yeah, it has all 3 acute angles. So all these angles there, they don't have to be equal, but they all have to be less than 90. The one that has 1 is the right triangle, one right angle. You can't have a triangle with more than one right angle. It would end up like you couldn't even make it, right? It wouldn't be a triangle anymore. So a right triangle can only have one right angle. And an obtuse triangle can only have one obtuse angle. So equiangular, 3 equal angles, acute triangle, 3 acute angles, right triangle, 1 right angle, and then 1 obtuse. So here we're just looking at classifying by angles. So if I notice that one big angle, so this is going to be an obtuse triangle. 60, 60, 60, we said that that is an equiangular triangle. Equiangular. 70, 42, and 68, which one is that? You're right, acute. All the angles are acute and little, less than 90. And when it's exactly 90, it's a right triangle. So there's 4 different ways to classify a triangle by angles. Now, a lot of times these different classifications like coexist, right? So we can look at a triangle and classify it by sides and then also classify it by angles. We're just going to circle here. So if we look at this one here, do you agree that it's got 2 equal sides, so it's isosceles? And then it has a right angle, so it's right. So that is what we call an isosceles right triangle. And just a little FYI, isosceles right triangles are always going to have the 2 legs of the right triangle equal. Oops, that's the 7. It can never be like a leg and a hypotenuse, right? Because the hypotenuse is always the longest side. In number 10, I see a 115, so that makes it obtuse, kind of jumping there. And then 2, 3, and 4 are all different, so scalene. So that is a scalene obtuse triangle. What about number 11? Well, 2, 2, 2 is equilateral. 60, 60, 60 is equiangular. And it's also acute because all the angles are less than 90. By the way, equilateral and equiangular always go together. Excuse me, always go together. This one is what? It's acute, right? It's also isosceles. I think that's it. Acute and isosceles, yep. All right, some more triangle vocabulary. The word vertex we've had already. We know that vertex means corner, right? So the corners of the triangle here would be like L and K and J. We already know that a side connects corners. So the sides would be like KL, LJ, KJ. The whole segment is a side. But really, the most important word here is this opposite idea. Sides are opposite of angles. And when we say opposite, we really mean across from. So here it has in this picture that side BC is opposite angle A. So here's angle A. So this side is opposite the angle. This is a really important concept that we're going to use a lot this whole year. One way we explain it is we'll say, like, pretend you are at angle A here with a hose and you're spraying water. Where does that water land? Well, it would land on that entire side. So the whole segment is opposite angle A. So in each picture, they're going to give us an angle and then say which side is opposite of that angle. So here it's angle X. If I go across or opposite of angle X, do you agree that YZ is opposite of angle X? What side would be across from angle M here? You're right, NO is opposite angle M. How about opposite angle C? DE. Now you're getting the hang of it. And the last one is what's opposite of angle Z? XY, right? So sides are always opposite angles. So this is our kickoff of Chapter 4 on triangles.